All right, so I just want to make a short video to give you some instructions for the simulation. That's your lesson for this week. So it's been really helpful in some of the other classes. I would really appreciate your feedback if you find it helpful as well. It's a simulation I've done with automotive and they found it really good. I had a number of students pop by the office to say what a good simulation it was to help them better understand the electrical theory. So fingers crossed, it's going to be beneficial for you as well. So this activity gets you to work through a simulation. It basically reinforces the math you've just done, gets you to think about what happens in some scenarios, but it's a very guided lesson. The first part, you're going to look at series circuits. So you want to do this assignment on a separate piece of paper just because I haven't left really workspace, because to leave workspace, I'd have to make about an 8-page document. So just a sheet of loose leaf, any kind of paper that you happen to have available. And I'm going to grade it like a quiz. So it's not really high stakes. I usually grade it equal to 2 quizzes just because of how long it takes. So it's a full lesson. So what you'll want to do is you'll want to go to the simulator link. And you'll want to follow through the simulator. I'm going to show you the simulator in a minute. Now, one note is just to give you some extra incentive to work through it. Your final assessment will have a component which you could use the simulator for in order to help you out. It'll be your choice whether you use it or not. It won't rely on using it, but it will have an activity component that will be kind of a build and explain scenario. So part 1 of the activity, you're going to build a series circuit. You're going to use 2 light bulbs. You're going to leave them with the same resistance. So I'm going to show you in the simulator. If you just pull the light bulbs into the simulator, you will find that they have the same resistance automatically. I want you to draw the circuit for me. I want you to label them with their default values, and I will show you how to find them. Then using Kirchhoff's laws, I want you to find current, voltage, and resistance, and power consumed by each of the bulbs. So basically solve the circuit like you would have done in your last lesson. Then we're going to do some analysis of what happens to voltage and what happens to brightness. You can experiment with a simulator and make adjustments to your predictions if you wish. Then the next thing you're going to do is you're going to change the value of resistance in one of the bulbs, and you're going to go back and basically prove your answers to these questions. You can check your calculations using the ammeter and the voltmeter. So this is one of those assignments that really, if you follow through correctly, there's no way you could have wrong answers, okay? Once you've finished working through the series circuit, you're going to work through a parallel circuit and you're going to do exactly the same activity, but this time you're going to put 2 light bulbs in parallel instead. And I want you to observe in the simulation what happens, and it'll let you kind of visualize what happens in each of the wires. Again, you're going to change the resistance of one of the bulbs and observe what happens when resistance changes. So you've covered all the math for those 2 pieces. You should really be able to do those without the simulator, but I want you to use it to help reinforce your understanding. Then when you get to part 3, we're going to deal with a combination circuit, and I've labeled points on it A, B, C, D, E, and F to help you identify where I want you to take measurements. I would like you to do this lesson without having seen the combination circuit lesson that follows in lesson 9. The reason being, I want you to explore what happens. I want you to make some reasonable predictions. And I think it will actually help you as you work through question 9, figure out what happens. So this is one of those, and I know part 3, because you don't have all the theory, you may find you don't answer a question correctly. That's okay. That's part of the explore and explain and create inferences. Now, after you've watched lesson 9, if you want to go back and make some adjustments, that's perfectly acceptable. But I really would like you to work through the simulation before you've got the theory for how to work with a combination circuit. We often learn best and retain best by doing explorations. I'm limited as to what explorations you can do, but I think this is a valuable one. So you're going to build the circuit in the simulator. So this is our circuit here. So you'll notice we have a series section. Here we get 2 resistors in series, and then this branch and this branch are in parallel. So we're looking at a series parallel combination circuit. Oops, I need to do a couple question edits here because you won't enter your results in the SAM quiz. My apologies. That's you're just going to attach them. I'll edit that so when you download your instructions, it doesn't have that error in there. I want you to look at these questions. How many paths connect? What's the measured voltage, etc., and answer each of these questions. I don't want you to redraw your circuit in the simulator, but I want you to take a look at this circuit and I want you to think about what the voltage would be and how the calculations would work. Okay, and you'll want to kind of go back and forth to the values in your last one in order to compare how this circuit could be an equivalent circuit of the one that you had in question 13. And then for question 13, question 11. And then when you get to question 13, we have a resistor in series to the battery, and then we have a separate parallel branch. And I want you to predict what would happen, predict what the values would be, and then do some measurements in the simulator to verify are your predictions correct. So this is kind of like a simulation lab activity. So hopefully it's not too difficult for you and you find things okay. Now, I'm going to show you how the simulator works. So I actually have the simulator here. I'm just going to have to stop sharing for a sec and share a new screen. So when you open the simulator, you're going to get a screen like this one. Go into the intro mode instead of the lab mode. The lab mode has some extra parameters that we can control which aren't necessary for you to control. So I want you just to go to the intro lab section, and you will find over on your left, you'll have all of the components that you can use to build your circuit. Over on the right here, I'm going to actually get rid of my thumbnail video completely. You'll have some options here as well. So you can show current. You can show current as electron flow or conventional current. It really doesn't matter which one you decide to show. You can add labels for values. You can also add values, and you can experiment with what you see when you click both of those. You may see values that are very useful to you. This is your view mode. So if you click on the battery mode that looks like a battery, it's going to give you things kind of in picture form. If you click on the schematic mode, it shows things as lines. Now, personally, I like seeing the battery mode because it shows our current a little easier. And it's also going to help us see brightness. So I would recommend sticking with this mode, but you can toggle back and forth between the two in order to help you with drawing your circuit. You're going to have access to a voltmeter here and an ammeter here, and I'll show you how those work as well. So I'm just going to make a really simple circuit. So it's just drag and drop. So we drag a battery in, we drag a wire in. We can grab a light. I'm going to use a light bulb rather than a resistor. So you can connect your light bulb just once you drag it over. Once it's blue, you know you've got a connection. Here we're red, so we don't have a connection. You can rotate them very easily. Connect another wire. So I've got a wire connected. It's blue, so we have a connection. And I'm just going to leave. And I like to do things in nice grids. So. And here you have a switch, so you can drag a switch in if you want. And then we'll put another wire in to connect the two. Okay, so we have our circuit. Now you'll notice when I close the switch, you see your electron flow. Open the switch, you don't see the electron flow. Our battery, or our light bulb rather, has these yellow lines. The yellow lines are equal to the power, so that gives you a way to visualize power. Now you know power and voltage are related, so I'm going to click on the battery, and you can control the voltage of the battery. By default, it's going to be 9 volts, but we can, increasing the voltage of the battery, you can see the effect on current. It's much faster, and the brightness is higher as well. Decreasing it, you can decrease the brightness. So that's how you'll observe brightness, is you'll look at the intensity of the yellow lines around the bulb. So that's how you adjust voltage. Just click on the component. For the light bulb, you can adjust the resistance of it. So click on the light bulb and you'll just change what the resistance is and look at what happens. Okay, so pretty straightforward in order to use. Now, how do you use and just for showing sake of different views, this view shows your electron flow. I guess this one shows your electron flow as well, but it just doesn't show your brightness. You could also show conventional current flow and it just shows it using arrows. So you can kind of play with those different view modes for the one that's easiest for you. But when you're comparing brightness, you'll definitely want to click on the picture that looks like a battery so you see those lovely yellow lines. Now, for part 3, you're going to want to measure some voltages. When you're measuring voltages, you're always going to measure across a component. So this allows you to measure just like you would with a regular voltmeter, but a little less parameters to adjust. Your black on one side, your red on the other side, and you'll see it gives us what the voltage drop is across the light bulb. If you switch the direction around, we just get a change in the sign, okay? So depending on your direction, you'll get a sign change. So that's really, really easy to use. Voltage across a battery. If you're not sure and you don't want to click it to find out, there's how you would adjust. Okay, so you can measure the voltage across any particular component. Now, if you want to do current, you've got the little ammeter. Just click and drag the little circle over any part of the wire. It'll tell you the current. If you click values here, you'll notice the values. It'll tell you your voltage. It'll tell you your resistance, but it won't give you your current. You'll notice it says 0 volts here. That just tells 0 ohms here. It just tells you the switch has no resistance. All right, so pretty straightforward. If you want to reset, you're just going to click this little yellow orange button down at the bottom corner. That'll reset and clear everything for you. Put it back to your original mode. So there's lots of different options. The only ones you'll really need to use is you'll just use wire, battery, light bulb, and a switch. But if you want to experiment with what happens if you throw a fuse in, that's perfectly acceptable. We won't need to deal with the dollar bills, coins, or some of the others. Those are for doing some more elementary experiments with. So hopefully that gives you a good background as to what you're going to need for this lesson. And if you have any questions at all, don't hesitate to ask, but it should be fairly self-explanatory. And as far as grading goes, I'm looking for good answers. For the first 2, I'm looking for correct answers. For part 3, where you're exploring a combination circuit, I should see correct answers, but I'm expecting that there may be some incorrect hypotheses. That's what we call it in science. We need to make predictions. It's possible you could have some incorrect predictions, in which case that will be accommodated for. And in that final section, grading for correctness won't be as essential, but grading for completeness will be. Again, any questions, pop me an email, let me know.